All right. Good morning, good afternoon, wherever you're joining us from. Welcome to today's webinar. I'm Melissa Lazaro. I'm the Director of Marketing and Communication here at MindPrint Learning. And we are so excited that you've joined us today. We've got a full deck of beautiful content to go through. And at first, I just want to go over a few housekeeping items, and then we'll go ahead and start with introduction. So thank you for joining us today. Let me go ahead and share my screen so we can get going. So as a matter of housekeeping, all attendees have been muted to limit distractions, and all questions can be put in the Q&A. We'll be answering those live. We have our Senior Director of Learning, Vicky Algieri, that's going to be handling and facilitating questions today. So any question that's asked, if it's a real quick answer, then she'll go ahead and answer that in the Q&A, but some questions will be reserved for the end for everybody to benefit from. This presentation is going to be about an hour long, and that will include Q&A. And as you know, you got the warning. Today's webinar is going to be recorded, so that if you need to share it with anybody in the future, you'll receive an email within the next couple of days that will have that recording. So welcome. What it means to be a math person is going to be kicked off with Susan Beshel. She's our facilitator from MindPrint Learning today. Susan is the Director of Data and Curriculum at MindPrint Learning. Susan is comes to us with 20 years of experience working in both public and private schools. Started as a teacher, became a math coach, and then held several different district level positions, creating effective and engaging math programs for students. She has a BA from Bucknell University and a master's degree from teaching from Fordham University. Next up, we have Stephanie Bisher, who's going to be covering how to use a whole class cognitive data to improve the mindset and performance with your students. And Stephanie is a lead math teacher at Kilgour School. She's got over 21 years of teaching experience in elementary classrooms, and then transitioned over the last 15 years to teaching math to middle schoolers. Her strengths include differentiated planning and instruction and incorporating real life experiences into her math instruction. She's the mom of two very energetic 10 and 12-year-old boys, but she's been using MindPrint to help guide her planning instruction over the last few years, or several years, I should say. And then finally, we've got Mira Halpert. Mira is an author. She's a developer. She's the president of 3D Learner. And Mira has a degree in developmental psychology. She's got a master's degree in education from the University of Michigan, and she's worked with children all of her life. And her real passion is to figure out how children learn best and to assist parents and support parents in that journey of the learning process of their child. Mira and 3D Learner support children all over the world and of all ages. And so we thank you for joining us today in today's webinar of Redefining a Math Person, and I'll kick it over to you, Susan. Thank you. Oh, Susan, I think we got to unmute you first.
You got to unmute me, and if you can go to the Who is a Math Person slide, then we'll be good to go. So who is a math person? If you're a math teacher in the room or an educator and have experience in math classroom, and you ever told someone that you're a math teacher or you teach math, I guarantee you've gotten some type of response that's either in the one side, oh my God, I love math, or more commonly, I get, oh my God, I'm not a math person, or I have nightmares from algebra or these time tests, or parents now send to me, I can't even do my 5th grader or 2nd grader's math homework. And unfortunately, this labeling and identification isn't something that starts in adulthood. It actually starts really early, and our youngest learners are already forming their beliefs about what it means to be a math person and where they fit into that particular definition. When I was teaching, I put up a question on the board and says, what does it mean to be good at math? And I had my students all go put up their answers, and their answers only included, you have to go fast. I need to get to the next level in my rocket math. All of my work is correct. I'm getting this score, or I'm going to be like so-and-so in the class whose hand was always up first, always finished first, and quote unquote knew the answers. None of the answers included, I'm going to be a good problem solver. I think flexibly about numbers or ways to solve a problem. I'm able to explain my thinking to someone else. I'm able to show or prove why this is true. And it's become acceptable not to be a math person. And today we're going to figure out ways that we can change that. And the reason why I put this cartoon up is because as I've been talking, you may have been looking and you may have instinctively gone to one side or the other. I know I'm going to the equation side, but I'm a math teacher. And looking at the left-hand side, you see this picture, and it's pretty nuanced for us to know that both sides are exactly the same mathematically. But to ask the question is, why is the line so long on that picture side? Why do problems like that trend on social media and have thousands of people willingly responding on their free time and arguing in the comments about what the right answer is when they're not math people? And it's because there's a story to tell from those pictures. And it's wondering, what can we do about that and bring it into our math classrooms? Melissa? So as we think about what we can do about that, here's the data that teachers should be considering and triangulating. We know that one data point, one assessment never tells the whole story, particularly when it comes to academic data. And so feeling like you're a math person and being good at math affects and is rooted in all three data areas. When you don't see yourself as a math person, your motivation, your mindset, your willingness can put in the effort can really suffer. It's a what's the point attitude, and it can affect your work habits, affects how much you're then learning, how you're performing. You get those lower grades, and then a really preconceived notion about what you had about yourself is then solidified. And there are a lot of good practices to support SEL in the classroom. There's productive struggle routines, growth mindset routines, but those alone are not going to shift students' beliefs if they're not getting the academic results to match it. You can stick a yet up on your bulletin board, but if you're not switching your practices and getting the students the strategies they need to improve their performance, you're not making the progress you need. And so math teachers always, I think probably more, I mean, I've spent most of my life in the math world, but we are inundated with academic data. We've got the quiz grades, the test grades, whatever program your school uses, iReady, Alex, IXL, MyPath, normed assessments, MAP and ERBs or state test. And they all boil down to one thing. It's like what a student does or does not know about a particular content area. And it misses the point of what a teacher's supposed to do to help that student to start learning and actually remembering that information as they go forward. And so what is the missing piece there? And that's the cognitive data. When students know their strengths and can learn and study more effectively, their academic data shifts, and then their social emotional beliefs shift as well. So if you've been in our webinars before, or if you're a MindPrint user, you're very familiar with the learning pyramid. So I'm not going to spend time today going through it all because I tend to be a talker and I'm not going to have enough time, but I encourage you to go and look at one of our earlier webinars or reach out if you want to learn more about the science of learning. But this pyramid really shows the different aspects or skills that drive a student's ability to understand and new material, manage their work, remember, and then actually put it into practice. And I'm going to break it down. It's right now in a pyramid format, but I'm going to overlay it with some math practices to show what it looks like in an actual classroom and where a student's success is driven from and where the breakdown may be occurring and why a student might be having challenges. So I saw this image on Twitter this week and I stole it from a very popular math educator and it resonated with our topic. And so in either the classroom or a student's home environment, the perception starts in the earliest grades that procedurally knowing how to solve problems and quickly is what it means to be good in math. You have first graders who come in stacking their numbers and learn from their parents. I saw this week in a pre-K class a bunch of worksheets being used to practice their math facts or the overemphasis on the traditional algorithm. And that all adds to the notion that if they can purely add, subtract, multiply, or divide big numbers, they're really good at math. Melissa, you can do a couple clicks. There we go. And along those lines, being really fast with your math facts is what makes you good at math. They don't care about number sense or strategies. That's not what's being measured. If you don't fall into that fast procedural group of kids, you begin to think that math is not your thing. When I present to parents about, the ways that their kids are learning math, I tend to get pushback, less so more recently, but particularly earlier when the parents are wondering why their kids are learning different strategies or why they're using models or drawing pictures or using tools. And they're so focused on using multiple step algorithms to get their kids moving, using procedural knowledge, I told them, I'm like, okay, that's cool and all. Like, we want them adding, subtracting, multiplying, dividing. But if that's your only focus, by the time they get to middle school, they're actually out of business. They're replaced by a calculator and they lack their foundational understanding. And they begin to then question themselves as mathematicians. Our goal and what we're aiming to do is actually build problem solvers. So in reality, rich and engaging math classrooms are going to include all of these other things. It's including practices that allow students to explain, discuss, respond to others about their math. The contexts are rich and meaty so the kids can talk about it. Students with stronger verbal reasoning are able to access and understand the material as much as the kids that have stronger visual abstract reasoning and purely want to look at the numbers. And so then we also have students who are asked to visualize and model the math. Math becomes dynamic, and students with stronger spatial reasoning are able to show and prove the how and the why behind the concept and the procedure and why that's true. And when you put all three skills together, you help every student have a really strong foundation. So we do all this work and we get them, all the students learning. And then the important piece is remembering the information. So we talked a little bit about like the visual memory and the verbal memory. And I could actually spend a whole webinar talking about retention and math and how that relates, but I don't have enough time. But I'm going to take the moment now to say that if we spend all the time on understanding and learning the math, and we don't focus and provide effective retention strategies for students, it ends up that they lose it. And then the next year's teacher blames the teacher before that these kids don't know anything. So when you have a knowledge around your stronger memory skill, it can really aid in the retention and the strength of how that student is carrying forward their information from year to year. And then a potential blocker that happens in math, while we have and we want really rich math problems in the classroom, and there are problems that have multiple solutions, a lot of math comes down to one right or one wrong answer. And if you're not attending to precision, if you have some blockers around working memory or attention, or your processing speed is too fast, you can end up with scores or performance that doesn't match your actual conceptual knowledge. And so what this could look like is how the students are organizing their work, holding on to steps of their problem, recalling their formulas or facts before they're mastered. And if they have weaker memory, they may have missed some parts of the lesson, or they're not holding on to key parts of the problem when they're doing it. And they often make a lot of careless mistakes. And we know that they're not actually careless, but they are the mistakes that cause the student's score to not match what they conceptually know. And that's where their misperception comes in. You can probably think of these students in your classroom as the ones that zoom through their work, they drop the negative signs, they forget the second part of their problem, or they're not able to juggle multiple things in their head while they're solving a multi-step problem. And then finally, my favorite part of math is the problem solving. Application problems, rich tasks, these really ask the students to go beyond solving an equation and answering questions that have usually a big open space on the paper. And that is what sends some kids into a panic. Knowing where to begin, or that there are multiple paths or solutions, can be really overwhelming. Students often can get stuck before they even read the problem. Their hand goes up and I'm like, wait, did you even read the problem? Or they don't know where to start. Or if they do know where to start, then they get stuck. They often can dive straight into a deconstructive struggle instead of a productive struggle. And as problem solving is the heart of math, we really need to attend to students' flexible thinking to help them put all those pieces together. And so hopefully you can see that all these cognitive skills play a really important role in math. Educators, we need to incorporate practices that highlight the students' strengths, no matter where they are in this design. Attend to potential blockers so that they don't identify based on a blocker instead of their ability. Help them understand, remember the material, and then be able to problem solve. And it doesn't just stop there to shift mindsets. You can flip. When students know their strengths and potential blockers, they can use their strategies to build their self-efficacy and awareness. You're right, you can go. So it's not just me saying this, I promise. While you may, and I can't follow along with the chat, but I think I see agree. So I'm hoping that you guys are agreeing with what I'm saying and you're connecting to what I'm saying. We're not alone in what you've noticed in your classrooms, what you've seen, and what I've just said hopefully resonated. The research stand behind us. So these 9 cognitive skills here actually predict over 50% of math student outcomes. And the weight does not lie on the visual abstract reasoning alone, as people might think it does. It actually is, Melissa, you can click through. Is it not working? Or is mine frozen?
No, I got it. I think is it back up?
I don't see it on mine, but I'm just going to say it anyway, because then the case studies are more important than me anyway. So I'd rather get the teachers talking. But basically, what does the research say? It's that visual, verbal, and spatial reasoning with flexible thinking have the largest effects on student math performance. It is not just visual abstract. Verbal reasoning actually is the strongest. And so how do we use that information to make some changes for both our whole class, which Stephanie will talk about, and for our individual learners, which Mira will talk about? And I'm going to pass it over to Stephanie.
Okay. All right. Good afternoon, everyone. So I am Stephanie Bisher. As Melissa said, I teach 6th grade math to 3 classes of 6th graders. And I'm going to talk to you today about how I kind of shifted my whole class using MindPrint. I started working with MindPrint or using MindPrint the end of 2017. 16, 17, 17, 18 school year. I can't even keep track anymore. And worked through, actually started with looking at just how to group students, and then started looking at it at a more individual basis. So today, what I'm going to talk about is how I've used MindPrint as a whole class and to work with creating small groups and creating focus groups and working with putting students into collaborative groups. So Melissa, if you want to go ahead and go on to our next one.
Yeah, I just want to make sure. Is everybody able to see the screen now? I just want to make sure that, are you able to see the slide deck?
Yes, I see.
Okay, great.
Perfect. Okay. So I think you can probably click a couple of times so we can get all of this information up here. But in terms of looking at our academic, our cognitive, and our social emotional data, as many of you are using, you're probably using your state tests. You're using some sort of growth assessment. We use MAP in my school. I also use Acadians for benchmarking and progress monitoring, and then just classroom assessments, which I'm sure all of you are using lots of really great assessments that you've created. And so adding MindPrint onto that as a layer, as a whole class, and we're going to see here in a minute, we saw strengths of a lot of those skills that are really critical to math, and that being those abstract reasoning, the perceptual, spatial perception, all of those things that Susan was talking about just a little minute ago, my students are very high with, and those are some strengths that they have. So they're really quick on the wanting to solve problems really quickly. They're wanting to get the right answer rather than thinking about the process and really understanding what it is that they're doing. I also have a lot of students who come to me who come in with that mentality of, I'm just not a math person, and I'm never going to be good at this, and this is not something that is my strength, so I'm just going to kind of get through class. And so it was trying to shift those kind of 2 focuses. Go ahead, Melissa. So this is going to give you kind of an idea of where my class is. I have a pretty high performing class. About 70% of my kids would be in like the top 2 categories on our state test. So I have some really, really high achieving students. This is this year's MindPrint summary, which is really interesting. And you can see that verbal reasoning, abstract reasoning, spatial perception are really, really high strengths for my students. But flexible thinking and verbal memory are areas that many of my students needed support. So I'm going to talk to you a little bit today about how I've approached that with my whole class and some changes that I put into place. All right, we can go ahead to the next slide. So these are my 2 favorite reports in MindPrint that I love to use when I am trying to put students into collaborative groups. So this top report, you'll see it says a group view. And this is where I get information about my students who are doing really well, my students who I need to nurture or challenge, which I'm going to talk about in a little bit, my students who I'm watching, and my students who I need to support. So if I'm making small groups for, say, stations, or if I have a tutor coming in, this is a great resource to go to, because if you hover over the numbers that are there, those students' names pop up. So right away, I've almost got small groups created for me. The student data at the bottom breaks down more of the MindPrint data and those reasoning, executive function, and speed and memory. And this is what I use when I create my table groups. So for example, if you notice student A and student C, if you look over on the right-hand side where the memory is, those two students both are in need of support for memory. So I know that when I'm going to be grouping my students together, I don't want to put those two kids together at the same team, because they're both going to have weaknesses in that area. I'm going to put them with a student who maybe has a strength in that area, who can help work with that student to get them, or just help with strategies, because they have strengths in that area where the other students don't. So it's just a great way and a great visual. I'm a color person, so I love that I can look across the board and see where these students' individual strengths are and where their weaknesses are. And it really helps with putting groups in, or students into groups, to help that with collaboration. All right, so let's go ahead to the next one. So after doing all of that, I'm going to talk to you a little bit about the things that I put in place, knowing that flexible thinking was a weakness for a significant portion of our students, and then also that the verbal memory was a weakness. So the first kind of plan or thing change that I made was the beginning of the year, started working with the students on a detailed rubric, or what I call my problem solving scoring guide. So where Susan was talking about how problem solving is so critical to the math classroom, I really needed students to have something that they could break down those problems. So when they came across a really rich problem, they had somewhere to start. So I worked with actually our team of math teachers, and we created what we call our scoring guide. And it kind of walks students through how they can approach a problem. So we start by just reading it, reading the problem carefully, circling important numbers that you see, and underlining or highlighting what it is that the problem is asking you to do. That's just the first step. So at least students have an entry point to the problem, something they can start off with. Then we give them our recommendation is to create a visual of some sort to help understand the problem. And while you're drawing, you usually can help you figure out what operation or operations you need to use, which could lead you to writing an expression or an equation, if necessary, to solve the problem. So those are kind of like the process parts of our scoring guide. And then we get students into the point where they're solving, working through it, showing all of their work, and then writing answer statements, including units. And all of these are listed as checkboxes, and students have a copy of these at their table, in their notebooks. They're posted around my room to remind them, if they don't know what to do to even start approaching a problem, it's a place to start. Which then leads to this feedback revision cycle, which I started, I think 2 years ago, and it's the best thing that I've done in my math class. I've really turned problem solving into something similar to a writing process. So our problem solving, utilizing that scoring guide, students are then provided with feedback. It could be pointing out things that they did well, things that they need to improve on, if they've got a small mistake somewhere. And during their problem solving portion of my class, their papers aren't graded. They're just, I will check if things are correct. I will provide feedback, and they have to keep revising it until they get to the point where they have a complete and thorough answer. The beginning of the year starts off, it's always about 6 weeks of really training them. They start off coming in wanting to give single number answers. And as we work, and as I give them feedback, and as I give them recommendations for ways to improve, what are we in February now? They're on cruise control. Their work is amazing now, after having spent several months of going through that feedback cycle. They continue to get feedback, and they're actually much more comfortable with making mistakes now because of that. They realize that their first attempt is not their final attempt. And then the final strategy that I want to talk to you a little bit about today is challenging yourself. especially knowing that I have students that are in that upper, really high, 70% of my kids are in those top 2 categories. I need to continue to grow those high kids. So finding ways to challenge them, I'm asking them, because a lot of these kids are kids who get the answer really quickly. So if you found the answer right away, what's another way that you can solve it? There's got to be another way that you can solve it. And we do a lot of sharing out and explaining processes. And I love it when we have a problem where we can get 6 or 8 or 10 different ways to get to an answer. And the kids love to share and hear from their classmates as well. So extending it, visualizing it, what's another way you can do it? And then also, can you teach it to another student? The method that you use, can you explain to a partner or a friend? I think we're good on that one. All right, so the results, and this varies from year to year, but I am really, really impressed with the amount of student growth that I have seen, both on my state test and map growth. Just a little bit of data. Before I was using MindPrint, and I know I've shared this with a few others, but before I used MindPrint, my growth index for my students was around a 2, which if you have value added in your state, you'll know that a 0 is like normal growth and anything above that. So I'm exceeding the growth expectation. After I started using MindPrint and actually using it for my kids that I couldn't figure out and using it for my collaborative groups, my growth jumped from a 2, went from a 2 to a 3 to a 4.5. So it's really working with students. Map growth this year, I think my students from fall to winter had about 150% of their projected growth. So they're growing more than expected, which is amazing. And then this shift in mindset. I have students who are enjoying math. They like coming to class. They feel like they can do well. They can be a math person. That's one of my norms, my class. Everyone in the first norm coming in, all of our students are math students, and that's my expectation. And then the increase of complex explanations. Beginning of the year was rough, but after training them, they are really, really doing, like I said, we're on cruise control in February. August and September are always hard, but now they are using, they're turning in full explanations. They have complete sentences. They're including units. They're including multiple ways to solve the problem. And they're collaborating with one another and being able to explain things. And I think that is the end of my session, and I will be turning it over to Mira.
Thank you, Stephanie.
Thank you.
Awesome. Well, I don't know about the rest of you. And for those of you that are parents that are out there, we're all going, yeah, Susan and or Stephanie, that's my kid. Listen, even though I'm working with kids and I'm will be honest, I have the luxury of working with kids pretty much one-on-one. So we get to see these kids, and quite honestly, being able to have the MindPrint to be able to help us sort out. I've always been very strength-based. I got into this with, let's look at what kids can do versus what they can't. But quite honestly, it's been wonderful for us to be able to actually really have, everybody's data driven, right? And so being able to have the certain kind of data to be able to show what it is that where kids are strong, and kids themselves want to be able to see that. So I'm going to share with you a couple of kids that we did that are 2 very different. One is an upper elementary child. I think we can, is April. Okay, she's a 5th grader, and oh my goodness, she can, for those of you that know, she comes in like this. I hate math. Well, and I hate school, but I hate math. I'm no good at it. I don't get it. Now, I know we've all heard a lot of this, and I'm going to, sort of just get in this, and especially when we're talking about these upper elementary kids that truly have a negative feeling about math. This young lady is truly is a victim of the 2 years of COVID. And I say that because she just doesn't have a sense of math, a sense of numbers. And one of the things that you've probably, now you'll hear it from all of us today, is drawing things out. So a picture and visualization. And I think that you're going to go for me that I'm sort of visualization queen, and kids don't recognize that they actually have that ability. And the other thing that we're going to sort of talk about is aside from the numbers and the speed that Susan talked about, how people think about that and kids not having a sense of numbers. Also, have you noticed how math has become a lot of language and language based? So I'm really finding this, this I hate school, I hate math. And of course, the resistance to showing her work. We had the academic data of the iReady, which again, this will show you that she placed at the second grade level as a beginning of the year, right? Is a early fifth grader. You can imagine how much she obviously really didn't like math because she didn't feel she could do it. And it didn't, and I'm going to tell you that certainly the conversation from school to parents didn't really get through about sort of how really low she was and about a number sense. And I know we've talked about a little bit about verbal reasoning, but especially in the elementary school kids, I've really noticed from my background is developmental. We're noticing kids aren't looking for patterns. And sequencing is really off. I'd love to be able to sort of go back to sort out where this is. I don't know that preschools are doing sequencing anymore. I get a little nervous when I heard Susan say that she's gone into preschools and seeing these kids using paper, pencil, and math tests. That just kind of, pull out the blocks, pull out the clay, pull out whatever you have. Being able to do certainly getting that fine motor skill going, that's all math. I don't care, set the table, count the number of silver pieces you have. And I know it sort of sounds like I'm all over the place, but those of you that have kids that are older and younger, it starts very young, starting to be able to get the kids to be able to think about things in terms of numbers and pictures is really important. So when I did this assessment with the young lady, I had done a couple other things, but I really recognized really early that she had this visual spatial and visual aspect reasoning, and she was amazing at it. She didn't like to use words to explain what she did. And again, her idea that she couldn't do something, that was her overwhelming picture. But I had to truly overemphasize with her about how good she was at remembering those visuals and how good she was at remembering patterns. And we started building things. And when I say building things, like I was bringing out, what some of you may remember as old Cuisinart rods, but even as a fifth grader, using colored blocks that had various numbers on them, having her build, I actually sort of found her just playing with them and coming up with this and going, look, Miss Mira, this and this makes this and this and this. And it was, when 4 and 5 makes 9 and 5 and 4 makes 9, it wasn't like that was the first time that had ever been presented to her, right? But the aha moment for her was, wait, does that work every time? And she'd really start to be able to building it. And, we could all blame that 2-year block, but for her, that was just really, really important. And so we started to be able to work on these things, and attention, that was one of the other pieces. Attention is a real piece for her. The working memory was certainly a piece, that's processing speed. We talk about a little bit in terms of how long it took her to do it. Quite honestly, I think processing speed for her was much more of, I didn't really understand it. So for her being able to, trying to be able to sort out how a problem worked, and this whole idea about what was expected of me. When she started to have a number of strings of aha moments and looking for patterns, she started to actually, I can almost get out of her that she likes math. She'll smile, at least I feel like I'm on this progress monitor piece, that she's not in the hate category. She's in the, yeah, it's okay category. And actually, when Stephanie's talking about teaching other kids, I will do a huge, what we forget about modeling for kids. I will start out doing a problem with a student, and I'll start out and I'll say, look, I'll do the math. You tell me what it is the steps are, and then I want them to be able to teach it to me. And, now she actually has a smile on her face when she actually has to be able to use the words to be able to bring it to me. So what is it that we use? Manipulatives and pictures. Oh, I can't tell you. And even if you think you're not an artist or can't draw, I don't care what it is, just use them. I actually go back to the fact of nobody's too old to ever use manipulatives. our oldest son went off to an Ivy League college, and I'll never forget him coming. And I use this with kids all the time, this story. I'll never forget him coming home at winter break, saying how fun it was that in his high-level physics class, they were using straws and styrofoam balls to be able to build models. It's just really important for kids to be able to see these patterns and to support them and to use whatever tools. I'm also going to say about using graph paper. We please use big graph paper to be able to help them line things up. It makes an enormous difference for them. I must send copies of that to parents all the time. Being able to, and also even for her, especially at this age, we're trying to get her from down here to up here. Having her actually have an aid like a multiplication table is really vital for her. She loves the colors. Stephanie, you were talking about colors. Being able to have her actually quickly be able to do that while it is that she works on doing multiplication tables, she just needs to be able to know the process. Okay. Her scores, actually, that was what was really interesting. Her math scores from the beginning of the year till her second one, you know, we're here in Florida where we don't have a big test, but we do lots of benchmarking. They went up 48 points, which is awesome. But remember, she's a fifth grader. And when I first showed you those things, it showed that last year she was more at a second grade level. So we're getting there. So yes, is it a work in progress? But more than anything, reminding her every single time and multiple times through the time that I'm working with her about how strong she is. And it's like, oh yeah, it's kind of like she's forgotten that she uses that skill of hers and that she knows how to be able to use the manipulatives. The other student that I'm going to talk to you a little bit about is a little bit different. And because we work with kids from kindergarten through college level, Patricia is a junior high school, you know, wanting to be able to go to a high-powered college out of state, probably an Ivy. And she came to us, her older brother had come to us for SAT help as well. But she is a very strong, highly gifted. I've known this young lady since she was actually in first grade. She is, if I talk about sort of the definition of a visual spatial learner, she would be it. She's bilingual, but her language skills are, it's like you can see the movie is in her head. She just can't do it. She had a 560 in her initial SAT math, but she knew that math was stronger than her verbal. So we're like, we've got some work to do. She definitely has high anxiety. She has attention issues, so she's always working about time constraints. She actually had those accommodations for a long time. But she needed to be able to, she had her heart set on, well, gee, I really need to do really well on the SAT. And then she talked to another tutor who happened to be much more on the ACT side, saying, oh, you know, you're going to find that from her experience, the ACT was going to be a better test for her. And I will tell you that this part of the MindPrint assessment results was absolutely amazing for us, because I think we're great. You're going to be able to show it. Look at the differential between what would happen if she took the ACT versus the SAT. That was like a clear purple. I was going to say black and white about how the SAT for her was just an absolute no-brainer. She needed to be able to do this. However, she needed some work definitely in math, and she needed work in math in terms of laying out what was asking. So we've come up with, for the longest time, sort of when in doubt, draw it out. Yes, she would almost always look for probably the more complicated way to be able to answer a problem. And actually it was really my husband who did all of the math piece work with her, but using this as a framework made an enormous difference. I'm gonna go back to remember, patterning was really important for her to be able to recognize. And what we know a lot about the math problems in the SATs especially, is that there are multiple problems that are very similar. And once you pick up one pattern, you've really got a lot of them. And so, and more than anything, it was, yes, go back to read the problem. What is it that they're really asking? So it was absolutely, you know, okay, you're taking the SAT. Did you want to take the ACT just for the heck of it? Knock yourself out. Yes. Okay. She did that. And guess what she found? she did way better on the SAT. So now she's trying to be able to plan for, this is still halfway through her junior year. So she has a couple of more times to be able to try and top. For her, it was really necessary to be able to stop, pause, picture. She was definitely that one that wanted to get through it. She was definitely the one that's like, stop, take a breath, draw out what it is that the question's really asking, because you can come up with any kind of number, but what is it that they're really asking you to do? And she's like, oh, okay, now I get it. So she worked on it. Her math score improved 140 points. And that was just in the fall. She still has time to be able to work on it. She was able to complete the test with enough time. I just got a call from a parent yesterday asking about, these teachers want to be able to take my kid off the extra time through the College Board. I'm going to tell you, with kids with attention issue, that perceived time, extra time, is everything. So in her head, she knew she had more time, but she was actually able to complete the test with more than enough time to actually go back and check her work. And giving her clues about support about how to be able to help do that through the training. And then more than anything, I'm going to tell you that she truly thinks of herself, which is really cool. She thinks of herself as a math kid. And I guess, Susan, from that standpoint, I feel like that's the win. So
that's really encouraging, Mira. Thank you.
That's the big one. So, we've just found from our standpoint, where we get to be able to know the kids on a more personal basis, being able to have this kind of information to be able to help us, help our students, and help our parents help their kids when they recognize what their abilities really are. That's been a real positive way for us to be able to help get it what they need help.
Yeah. And it's data that's driving those decisions, right? So it's not
exactly
assumptions about the student themselves, or from a teacher perspective, you're using the data to drive.
We're not guessing, right?
Yeah.
We're not guessing.
Yeah.
And actually, kids don't recognize that. I mean, when I go back to that, to April, my first one, which was like, oh no, I'm really not good at anything. It's like when you showed her, like, it's not just me telling you. Like, look, you're really good at this. And she was like, oh, yeah. So having them own it.
Very cool. Well, before we launch in the Q&A, and if anybody, before anybody hops off before then, I just wanted to say thank you so much to our panelists today, Mira, Stephanie, and Susan, for just such rich content. And for those of you that are on the webinar today, I just wanted to remind you that MindPrint is the only K-12 solution that uses objective cognitive data to teach students how they learn best and provide strategies personalized to student learning needs and strengths. And so if you have any questions in the future, you can email Susan or myself. We'd be happy to answer any questions that you have. And I know Mira would be more than willing to talk to you about any questions that you might have offline too. But before we go, Vicki, what sort of questions do we have in the chat and the Q&A that we can go over today? Thank you.
Thank you, Melissa. And thank you so much, Mira and Stephanie, for sharing such inspiring success stories. So it's just wonderful to hear. We have a question in the Q&A, but anyone can please add anything at this time as well. This question is, I love this question because I ask it every single day when my daughters have math homework. But why do elementary math books tell students to show their work, but there isn't enough space to do it? And how can and how can we, or I'm looking at this from a parent perspective now, convince our kids that your teacher does want you to use extra scrap paper, but it's just not there in the workbook.
I'm going to take this one because it is a pain point. I actually did a curriculum review when I was at a math roundtable a few years ago, asking teachers what they used for their math program. And there was one math program, I'm not going to name names, and they're like, oh, no, we take index cards and we block out sections below. I'm like, the amount of time teachers are having to modify the pages just to give enough space for kids to work is insane. The curriculum we end up using does give bigger chunks of time. I don't have a solution. I was working with a 6th grader in pre-algebra yesterday, and she had 75 page, I mean, not really, but 75 questions on one page. And with weak attention and weaker executive functions, her transferring the problem to a piece of paper she wrote the problem wrong. She dropped a negative sign, solved it wrong, transferred it back. I'm like, this is a mess. So the systems are not set up in place to get the kids doing what we want them to do. I'm going to guess it's a moneymaker, because if they actually gave that space to print a producible workbook for these kids, graph paper, like Mira said, the bigger sizes, you can make the adjustable size graph paper, particularly for your younger learners. And then also be sensitive to some students where the lines of a graph paper is sort of visually overstimulating to them. So there's different alternatives that you can do. If you're the proponent of show your work, which I think we all are if we're in here, scrap paper coming up with a system, really making sure that we're thinking about the executive functions as we're planning and showing their work. Whether it's scrap paper and it's in a binder, whether it's a notebook, but giving the system to the student instead of leaving them on their own to come up with a system is really helpful. And there's one thing that I've always done, like you have line paper at home, if you're a parent and you're stuck and they are working on procedural math and, you know, algorithms, whatever. If you turn the paper horizontal, then you have columns on the paper instead of rows. And so then the kids can keep their numbers aligned place value wise. So if anyone can come up with a solution, I don't have it. And writing your answers in Google Docs with math equations is even harder. And I've actually talked to someone at Google Education. She lives across the street. I was like, hey, what are you doing about the fact that we can't write math equations in Google very easily? And she goes, is that a problem? I'm like, yes, it is. So I don't have a good answer for that, but it is a pain point for all of us math educators. And it reinforces the notion that you can just write an answer, circle it, and keep moving on.
And not that I'm here to plug other companies, but Microsoft in OneNote has a really cool feature where you can show your work if you have a smart tablet and lasso it and create computations and stuff. So something to look
Can I
into.
just
But I know
make-
Stephanie wanted to comment too.
Yeah, I'll jump in real quick
We'll
too,
get you, Mira.
because I am in the same boat with that. And I usually, so what I do with my students is I give them the choice of, usually there's about 8 to 12 kind of word problems for each lesson or what I'm working on. They have to pick 4. And so they take their paper, and I have to train them to do this as well, but they take their paper and they fold it in half. And literally this entire section is one problem. And then this is one problem, because there's room for them to show their work, but then there's also room for them to get feedback and then make revisions. So there's a ton of space. They may not use all of it, but I'm only doing 4 problems per sheet of paper. And it could be graph, and I have 4 different types of paper in my room. I have just blank white copy paper because some kids like that. I have large graph paper, I have smaller graph paper, and I have line paper. And the kids know where to get it and how to use it, because something's going to work different for every single kid. But that's the best solution that I have for now. You have that problem that Susan talked about of transferring it from the book to the paper, which can be a challenge. But that's my little tidbit.
I am going to second what Susan said about, especially for the parents that are out there, give the kids, make the stack of paper right there for them. Remember, these are kids that have attention issues. So if you get them to be able to go off to the other side of the room, even the other side of the desk, to be able to get paper, they'll find a million other things. The other thing that just is a quick tip, and I guess it's something that we developed, and I don't know why we still have it on desk, change your number line to vertical versus horizontal. It helps with negative numbers. For those of us that live in Florida, we don't have a basement, but for those of you that do, 0 is on the main floor, negative numbers are in the basement, and it gets these kids visually and kinesthetically sort of really thinking about the fifth differential. So there's just that.
I saw some conversation in the chat that I think we can incorporate a little bit in terms of strategies and how it relates to online and transferring, you know, if you talk about, and one of the people talked about Desmos, which is an amazing tool. It's curriculum, it's blown up everywhere. And how tools, like I said earlier about kids becoming calculators and then they're replaced with a calculator once they hit a certain level. Paper is a tool, pencil is a tool, manipulative is a tool. Teaching the kids explicitly how and when to use a tool is going to make the difference. Whether they're taking an online assessment, someone was mentioning, like, you get them to do an online assessment and they stop writing things down. It's really a habit that has to be formed, and they're not good. So here's what I like to break it down. And I have you know, not for, but like you think about your class, some kids are naturally going to come up with really great habits. And you're like, oh, they just are doing this. That's a really great structure that they've come up with, whether they were guided there or not. But the rest of the kids need to be given a structure and they need to be given the habits. As Stephanie said multiple times, you start in that beginning of the year and you're teaching them how to fold a piece of paper. The expectation is set that they have to use this tool for this type of problem. There's obviously opportunities to let them explore and get messy with the tools and figure out what tools working at what particular time. But that's really thinking about your classroom structures, how you can support them then, and then the really explicitness of what tool is best for your student, particularly when they're home and working independently. So in the classroom, you have the teacher guiding them and you can redirect if they've chosen the wrong strategy or wrong tool. But then they go home and they're left going, I don't know, I had 75 things, and the parents looking going, what did you learn? I don't know. Really being explicit in the practice. And I think that's where knowing the student's cognitive strengths and potential blockers is really effective, because then you're not just giving a huge like tool shed of like, here's everything you could be doing, instead of here's who you are. This works really well. And they can have that identity and work on that strength, because we can't change the curriculums and we can't change the fact that these kids have to take some tests online. State tests have been shifting. But what do we do about it ahead of time to help them feel prepared and be able to show their best, so they don't end up being here and then showing this. So it's a constant struggle.
Susan, as a real quick story, just then it was actually just sent to me. Especially getting these kids in the habit, the SAT and even the grad exams allow scrap paper. So getting these kids used to being able to use it is just really important, and truly having them do it, because you know, if they're and then take it and use it, that they actually really know. And then again, of course, that whole picture attitude, it starts really early with language about how kids feel about themselves and how they can do with math. I mean, it's just really awesome when they start to, I mean, that just starts to get ingrained with them, and it seems to be okay. You know, like we get the fact that reading is a big issue, and there's lots and lots and lots and talk about it. But if we don't get kids to start to think about how, yes, that math's okay, that they're good at it, we need to have that conversation, and it's all of us that have to do that.
It seems like it's really resonating in the chat, this idea of shifting, being a math person. So great job, panelists, on coming up with that title and giving us a theme. Any other additional questions, Vicki, that we should address? Might actually end up a little bit early today. Everybody can have 5 minutes of their day back.
Yeah, I think we're good.
Okay, well, fantastic. Just want to say thank you again to Susan, Stephanie, and Mira and Vicki, our fearless Q&A facilitator. Such a fabulous webinar today, and a great topic to be discussed by all educators and parents, and those of you supporting out in the educational therapy and tutoring line of work. We hope that you share this webinar with your colleagues when you get the recording, and please stay tuned for next month in our series of the science of learning. And I also want to just give a quick plug that MindPrint is hiring. We're looking for a sales and marketing assistant. So if you know of anybody that would enjoy the passion and working with this really fun group, you're not seeing the other 19 of us that are offline right now, but it's just such a great place to work where you can really put the passion in helping students. Thanks again. See you guys later. Bye-bye.